Hello students. In the previous video, we saw the fundamental concepts that are involved in support vector machine or SVM. It is a technique which is used for classification purpose under supervised learning technique. In this particular video, we will be seeing a hands-on or practical demonstration of applying SVM on iris dataset. First, a little theory will be taken and the remaining part of the video will include the hands-on practical implementation on iris dataset in Jupyter. So the iris data set has been considered where we are going to consider four features. We consider petal and sepal, two features, and within this we are going to consider petal width, petal height, sepal width and sepal height. So when we plot this, that is petal width and petal length, we get such kind of a graph where we have green square boxes representing setosa, which is a type of your flower, and the blue diamond boxes represent vesicolor. Now, to apply support vector machine on this particular data set, you can see three different lines. We will try to find out which is the best possible decision boundary that can classify these two data points. So if you see over here, the red line and the blue line, they are not spaced evenly on either side. So that is why they will not be feasible to be considered as decision boundary. Whereas if you consider the black line, the distance that is there between both these, they are equal, as well as we can use this black line as the hyperplane or decision boundary. See over here, we can observe that the spacing is more for the black line between the two support vectors as compared to that of the red line. So our feasible option will be the black line. So those dotted lines basically represent the margin and the black line represents the decision boundary, and those blue and green color boxes represent the support vectors which are lying closer to the hyperplane. So these are the support vectors. So as you can see, this is two-dimensional where you have got a line that is separating the two data points. When we consider three dimension, we have got a hyperplane. And what would be for n dimension? Yes, theoretically and mathematically, we can have n dimensions. So how you can draw it? Support vector machine draws a hyperplane in n-dimensional space such that it maximizes the margin between classification groups. So this is nothing but your gamma parameter which is present in SVC. You will understand these terms gamma when we take the hands-on. So this is basically the separating line. Here all the data points are getting separated. So And here in this case, when I'm having a linear SVM, there are some data points which are getting misclassified. So high gamma provides better accuracy as compared to low gamma, but it depends upon the data set as to whether we take high gamma or low gamma. So it is data set specific. We also have got something called as regularization, denoted by capital C. And in this case also we can see high regularization is better as compared to low, but again it is dataset or context specific, whether we have to consider high regularization to provide better accuracy or low regularization to get better accuracy. We will see even regularization when we implement support vector machine on iris dataset. Here we have got another situation where we have got your data set which is spread unevenly. So what can be done in this case? We can simply consider another line as Z and represent this two-dimensional data into three dimensions where we get a plane. And this Z is nothing but, as I told you all in the previous lecture, from 1D to 2D or from 2D to 3D, you need to carry out transformation. And the transformation is done with the help of a kernel. So it is nothing but your kernel. This transformation is your kernel. So kernel also, there are of different types like linear kernel, RBF kernel, radial basis function. We will see these kernels, how we can use it in SVM. Now coming to the hands-on implementation of SVM. As you can see over here, we have considered support vector machine on iris dataset. This dataset can be directly imported from sklearn. So we import the necessary libraries, pandas, and sklearn.dataset import load underscore iris. Iris dataset is easily available in sklearn. And we load this and we use a variable iris. Now we want to know what are the basic features in iris dataset. So we write down over here dir iris and it gives us the description. So it includes features like data, feature names, file name, target and target names. So if you want to check each of these, you have to simply write iris, which is the variable that you have used, dot. We want to check out for feature names. So iris dot feature names. So as we saw in the figure, we have considered sepal and your petal, and we are including sepal length, sepal width, petal length and petal width. These are the four features. Now it is necessary to create a data frame for this iris data set so that we can have a simpler visualization. So we consider df is equal to pd.data_frame for iris data, and the column is nothing but iris.feature names. So the four feature names are represented. So if you see over here, we can see first 5 rows with sepal length, sepal width, petal length and petal width values. So in all, we have got approximately 150 rows starting from 0 to 149. I have used df.tail to check the last entry. Now there is target variable in basic features. See over here, target. All right. In iris data set, and so a column name target needs to be appended. So data frame, the feature name that you want to give is equal to iris.target. So this is going to be appended with your table. So we have got target. Now the target which is there, it has got three values, 0, 1 and 2. 0 is nothing but setosa, 1 is nothing but vesicular, and 2 is nothing but virginica. So if you see iris.target names, because we have also target names as one of the feature. See over here. So iris.target names will show us the different values that are there in this particular feature. So iris.target, as you can see, these all represent your setosa. 0. 1 represents your vesicular and 2 represents your virginica. Now we will check in the table how many are setosa, vesicular and virginica. So DF is nothing but DF dot target. When I'm putting 0, I will be able to find out how many are setosa. So if you check, we have got approximately from 0 to 49 as your setosa. Now instead of 0, if we put 1, then we will be able to find out how many are vesicular. So 50 to 99. And 2, we will be able to find out how many are virginica. Now from one column, that is your target, we can generate another column, that is the flower name. So instead of using 0, 1 and 2, we want setosa, vesicular and virginica. So we can simply do this by using the append function in pandas, where lambda is a small function or transformation that can be applied on the target column and the new column can be generated. So what we have done, simply data frame flower name is the new column name that we want. Data frame dot target, this is the apply function and it is lambda x colon iris. You want to derive it from this particular feature, that is target name. So your x is nothing but it will check. If it is 0, then it will provide setosa. If it is 1, it will provide your vesicular, and if it is 2, it will provide virginica. So if you see over here, when you now execute the above cell and you type df.head, you can see 0 is setosa. Similarly, we can check out for others. So if you see in the tail, 2 is virginica. Now we'll do data visualization using matplot. So from matplot library, we import plyplot as PLT. You can use other libraries as well, like Seaborn as well as the others. This is the inline part. So percentage matplotlib inline. Now we need to separate these three species into three separate data frames. So data frame 0, setosa, data frame 1, which is vesicular, and data frame 2, which is nothing but virginica. So now what have we done is, data frame 0, we can see only setosa. Data frame 1, which starts from 50, we can see only vesicular. And data frame 2, which is for virginica. Now we will plot the scatter plot for setosa. So it is plot.scatter data frame 0. We have got sepal length and sepal width. You can use any color and in what way you want to represent. I have used the plus sign. So when you execute this particular line of code, for data frame 0, this is the plot that you get for 1D. Now for 2D, what we are going to do, we will take data frame 0 and data frame 1 and distinguish it with a different color, blue and red, and use different symbols, plus and dot. So we can see plus and dot over here. Now adding axis, simply plot.x label is x is for your sepal length and y is for your sepal width. So once you execute this, you can see we have converted 1D to 2D considering data frame 0 and data frame 1, where data frame 0 is nothing but your setosa and data frame 1 is nothing but your vesicular. So here in this case we are getting sepal length and sepal width. Now we will be doing the same thing for petal length and petal width as done here, as well as include the labels. So x-axis has got petal length and y-axis has got petal width. All four features will be used for training SVM, that is support vector machine, and classification will be performed on all three species: 0 for setosa, 1 for vesicular and 2 for virginica. Now let us perform the training using sklearn. So we are basically going to use model selection, which is there in sklearn library, and import train test split. Now before that we will have to drop the target and flower name columns which were present over here. These columns have to be dropped at the time of train and test. So what we are going to do is simply use drop command and drop these two. And now you can see both the columns have been dropped. And we are going to consider target, okay, which will include your 0, 1 and 2, which is nothing but setosa, vesicular and virginica. So y is equal to df dot target, and here you can see all the values from 0 to 149. Now we have got 150 records in our data set, and we will be splitting this into train and test. So we are considering capital X train, capital X test. Small y train, small y test is nothing but we are using train test split. And x, y test size we are keeping it as 0.2, which is nothing but 20%. Alright, so 80-20 is used. So if we want to check now the length, now here the splitting is performed. If we want to check how many records are gone for training and how many for testing, if we see over here length of X train, so if we see 80% of 150, 120 records. Length of testing, so X test 20% of 150, which is nothing but 30. Y train also undergoes the same scenario. Now we will be applying SVM because we have successfully split our train and test. So from sklearn.svm we import SVC, that is support vector classifier. And this particular function we assign it to a variable name model. And to carry out the classification or training, we basically use model fit or fit function, and we call X train and Y train to perform the training. So if you see this, you can see C is equal to 1.0. You remember what is capital C? I told you all initially it is nothing but your regularization, which is your 1.0. These are some other parameters. I also remember telling to you what is gamma. Gamma is nothing but your scale. And kernel is used for transformation. So here we have used RBF, radial basis function. Now what we are going to do, we have performed the training. Now we will use the score function to check the accuracy of our training. So it is your, for your test we will be checking. So after performing the training, we are getting approximately 93% as the accuracy. Now we can fine tune our parameters. As I told you, we can modify the value of C. Alright, so simply what we have done, C is equal to 1 is now replaced with C is equal to 100. So now let us see, after you do that, you perform the training. So we can see C is shown as 100 and we check the accuracy. So we can see here it is 93. So it is observed that the value of C did not affect the accuracy of the model. Now we can also change the value of gamma. It was scale and now it is 100. So you must be wondering, how do we put this value 100? How do we know? So it is simple. Just click on your SVC and press your shift tab. And here you can see what all you can include. So if you check out for gamma over here, we can give a specific value. I'll just check. See here. So gamma you can have scale or auto, or you can have float value. The default value is scale. Same thing you can do it for your kernel. We have used RBF. You can try for another kernel. So as you see, gamma, when it was the default value, which is scale, we had got approximately 93% as the accuracy. Whereas when you change it from the default value scale to 100, the accuracy of the model is reduced to 63. The same thing can be done for kernel. So if you see over here, we have initially taken kernel to be RBF. If we want the kernel to be linear, simply press Shift tab and you can check what type of kernel you want to use. So if you check over here, you can use linear, poly, RBF, sigmoid, pre-computed or a callable. So these different type of kernels can be passed. So here in this case, if you check, we have used linear and then trained our model, and we see by using linear, we are getting 96% accuracy. So this is how SVM is implemented on Iris dataset. Thank you.